yesterday we left off and we were doing craft time with Mrs. Cox. Do you guys remember when I cut out the little squares in the corners? And so now you understand that it needs to be squares and not rectangles that you're cutting out. So these types of questions are on every single math book from here on out. They're in every Algebra 2 book, every pre-calc book, every calculus book. They are always talking about an open top square box, or open top box. So we're making it out of a square piece of material that was originally 10 inches by 10 inches. And we're cutting equal squares from the corners and turning up the sides. Okay, so we're cutting out this little x by x square. So when we do that, we have this distance that's left right in here. Okay, and Claire said this yesterday. She was like, oh, it's, you have the original 10, and we subtract out the x and x, so we're going to have 10 minus 2x. So that's going to be 10 minus 2x there. And we're also going to have 10 minus 2x here. That's a minus. So when we talk about the volume of the box, these pieces, the length and the width, are going to be the same thing, the 10 minus 2x. Does everybody kind of visualize what's happening there? Do you guys get it? Okay. So when we talk about the volume of a box, it's always the length times width times the height. So our volume is going to be the length, 10 minus 2x, times the width, 10 minus 2x, times the height, which was x. And it says that we want to make an open box from a square piece of material, 10 inches on each side, by cutting equal squares. What size of square would you cut from each corner if the volume must be 48 cubic inches? So we want all of this to multiply out to b. Instead of b, we're going to write 48 for b. Okay, so there are ways to use a graphing calculator to solve this. We're going to talk about how to solve it using our rational roots theorem, right? The p over q. So we're going to FOIL it out first. So I'm going to have 100 minus 20x minus another 20x plus 4x squared. And I'm going to multiply by x. So when I do that, I'm going to have 4x cubed minus 20x squared minus another 20x squared, so minus 40x squared. And then plus 100x, and that's all equal to 48, right? So we're going to subtract that 48 over. So that's our function. So 4x cubed minus 40x squared plus 100x minus 48. Do you guys all see that? And we could start with our p over q right now, but the factors of 48, oh my gosh, the factors of 48, yikes. 1, 2, 3, 4, 6, 8. There's a whole bunch of them, yeah. So next thing, we have a GCF, right? Let's pull out the GCF. Do you guys see we have a 4, a 4, a 4. The 4 is in common to all of them. So we're going to pull the 4 out. And when we do, we have x cubed minus 10x squared plus 25x minus 12. That is much easier. Because now when I think about my p over q, I'm taking p to be negative 12 and q is going to be 1. So I'm going to have plus or minus 1, 2, 3, 4, 6, and 12, and plus or minus 1. Still a lot of possibilities, though. So let's think about this logically. We talked about this yesterday. If you have a big box that's 10 by 10, and you're going to cut a square out, what size of square would be too big? What size of square is going to make it run into each other? 5, right? 5 inches on each side, that's too big. Anything bigger than 5 means you're cutting out, like if you cut out 6 inches from the right and 6 inches from the left, wait a second, there's not enough material to do that, right? So 6 and 12 are automatically out. And the negative answers are also out, right? So we only have possibilities of 1, 2, 3, or 4. All right, so I would use those with your synthetic division, 1, 2, 3, or 4. I tend to pick things like 2 or 3 because I think like 1 and 4 create kind of a weird box, right? Maybe it's a really skinny box. I don't know what you would put in this box. Or a really, really flat box. Maybe like a tie. I don't know what you put in a really flat box like that. Do you guys get it? So you might have boxes that look like that, but I would tend to try like the 2 or the 3 first. So let's try I think 3. So I'm going to have 1x cubed negative 10x squared 25x minus 12. And I do my synthetic division. So 3 times 1 is 3. I get negative 7, negative 21, 4. Oh, it was a lucky guess. I couldn't remember if it was 2 or 3. I just guessed 3. Shoo. Don't you hate it when you have to try multiple things? Did that happen to you on your homework where you had to try more than one thing? And you're like, Mrs. Cox, why? So mean. At least you have calculators. You can always graph it and see. All right, so we've factored into, we still have the 4 out front, then we have x minus 3, and then x squared minus 7x plus 4. And the x squared minus 7x plus 4 doesn't factor, but it doesn't mean that it couldn't be a solution. So it might have an I solution, it might not. You could test the discriminant. Do you guys remember what a discriminant is? B squared minus 4. See the part under the square root, right? You could test that to see if it's going to be an I answer. B squared is 49 minus 4 times 1 times 4. Oh, it's going to be positive under that square root. So we got to do this. So we'll really quickly do this. So we're going to have x equals negative b, so negative negative 7 is 7, plus or minus the square root of b squared minus 4ac all over 2a. And it's not pretty, but we'll find the decimal version. So we have 49 minus 16, 33 over 2. So if I was putting this into my calculator, I would do like just the numerator first and hit enter. So go ahead and do this along with me. Make sure you guys get the same answer. Oops, so loud. All right, so I'm going to do 7 plus the square root of 33, and I'm going to hit enter. And then I'm going to take that answer and divide by 2. So when I do the first answer, so using the plus, was 6.372. Do we think that can work? Can you cut out 6.372 inches on each side? No. That's out. Too big. All right, but that doesn't mean the other one doesn't work. So 7 minus the square root of 33. Hit enter. Divided by 2. What do we get? 0.6277 something says 0.628. That one is still a possibility. What does the box look like in that case? Like a really short box, but really wide. That's like one for a tie. I don't know what would go in that box. It's still like a square shape though. So I don't know what would go. Like a painting, yeah, like on canvas. You could put a painting in there. There's no like, wouldn't be able to frame it. Just like something really thin. So it could be that, or it could be x equals 3. Probably 3, right? But that one actually has 2 solutions. Does that make sense? All right, and the last thing we have to talk about is the irrational root theorem. So it just says if we have a 0 that is in the form a plus the square root of b, then you also have a solution that's in the form a minus the square root of b. And that comes from the quadratic formula. Okay, so it says identify all of the real roots to 2x cubed minus 9x squared plus 2 equals 0. So my possibilities when I do my p over q are plus or minus 1 and 2, and plus or minus 1 and 2. So I'd have 1, 1/2, 2, and then 1 again, right? So 1, 1/2, 2, and then negative 1, negative 1/2, negative 2. There's 6 possibilities. All right, anything that you guys want to try? I think 1 does not work. Can you guys check that in your head? 2 minus 9 plus 2, is that going to be 0? No. So maybe we tried 2. Let's try 2. So be careful, this one is missing an x term. So we're going to put in 2, negative 9, 0, and 2. Then we do our synthetic division. Oh, it's not looking good. 2 didn't work. Negative 2 maybe? Actually, I think it's like 1/2. Let's do 1/2. Yeah. Yeah, you can just stop and cross it out, yeah. So let's try 1/2. So 2, negative 9, 0, and 2. Maybe. Yep, this one works. All right, so 1/2 worked. So that means we've factored into x minus 1/2, and then we have something with x squared. So 2x squared minus 8x minus 4. So we do have a GCF of 2, and that will always happen if like 1/2 is a solution. Like see how we can pull out a 2. So it's really like if you didn't like that x minus 1/2, you could put that 2 in with it. So it'd be 2x minus 1, right? So you could always do that. So 2x minus 1, not that that matters. And then we have x squared minus 4x minus 2. So sadly, x squared minus 4x minus 2 doesn't factor. So this is where you would do the quadratic formula. So you'd say, I know this solution gives me x equals 1/2, but this solution comes from the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So 4 plus or minus the square root of 16 minus 4 times 1 times negative 2 all over 2. So it's the square root of 24 that's in there. So 4 plus or minus the square root of 24 all over 2, which is 4 plus or minus 2 root 6 over 2. Just in time for Valentine's Day. Our little heart. Remember our heart? So 4 plus 2 root 6 all over 2 is going to be 4 over 2 plus 2 root 6 over 2. So what do we get? Yeah, 2 plus or minus root 6. Do you guys see why if you have an irrational answer, so if I had 2 plus the root 6, I also have to have 2 minus the root 6. Okay, it comes from the quadratic formula. Same with the i's, right? If you have an I solution, you have to have its conjugate as well. So our three solutions are 1/2, 2 plus root 6, 2 minus root 6. Does this make sense? All right, and then likewise, we can have polynomials with these. This one's kind of a complicated polynomial. I'll start this one out. Maybe we won't finish it. We'll see how we're feeling. So this one, if I have 2i and I have 2 plus root 3, what else do I have to have a 0 if I have 2i? Negative 2i as well. What about this one? 2 minus root 3 as well. So when I set up this polynomial, some of you guys were having trouble on your homework with this, it's going to be x minus every single 0. So x minus the 2i, but also x minus the negative 2i. So it becomes plus 2i. And then x minus parentheses 2 plus root 3, and x minus parentheses 2 minus root 3. So if I distribute that negative, it's going to be x minus 2 minus root 3 times x minus 2 plus root 3, like that. Some of you guys will know what this is, foiling it out already, because you know that something that's the sum of two squares will have answers of 2i and negative 2i. What is the sum of two squares that I'm looking for? Anybody know it? Greta? X squared plus 4. Not 4i though, 4. Do you remember x squared plus 4 will have answers of 2i and negative 2i? If you weren't sure, you FOIL it out. You get x squared plus 2ix minus 2ix, so it goes away, minus 4i squared. So that becomes x squared plus 4. I squared is negative 1. And then we would multiply this part out. Right? I'll just do it for you guys. You don't have to do it all. Do you guys remember you can take the x, you would take the x into all three things, you could take the negative 2 into all three things, or you take, and then you'd take the negative root 3 into all three things. And then you would simplify, simplify, simplify. I'd also taught you the shortcut. You can have x minus 2 squared minus root 3 times root 3 is not, root 9, which is 3. Almost got a bonus point. I saw you looking, Nick. You were like, yes. So we have x squared plus 4 multiplied by x squared minus 4x plus 4, and then minus 1, or minus 3. So x squared plus 4x, no, x squared minus 4x plus 4 minus 3 is going to be plus 1, and then you multiply this out again. So this is a long one. This would be like something that I would put as a bonus on your test. I wouldn't make you do this on the test because it takes a long time. I never want you guys to be panicking like you're going to run out of time. All right, x to the 4th minus 4x cubed plus x squared plus 4x squared minus 16x, just write the answer, plus 4. So your final answer should be, did anybody find it? No, you're just like, do it for us, Mrs. Cox. All right, minus 4x cubed plus 5x squared minus 16x plus 4. That's our polynomial. So one thing that does drive me crazy is when on your homework you guys just write the answer, because I'm like, there's no way that you just got the answer. So show your steps, right? You have to show your steps on things like this. So I'm not going to give you credit if you don't multiply it all out. It's magic. All right. So that is the end of 7.6.